For this video, we're going to look specifically at how to graph lines, and we'll look through a couple different forms. We've got slope-intercept form. We've got ones that are not in slope-intercept form. Then we've got identifying equations of vertical and horizontal lines so that it can help you graph them more easily. Finally, we'll look at how we can write equations of lines into slope-intercept form. So let's start with the beginning here. We're going to start with graphing lines in slope-intercept form or from slope-intercept form. Notice that whenever it says y equals or f of x equals, it's in this special form. We can, in any case, if we forget, always make an input-output table, a t-chart. If I pick values for x, I can find or calculate the values for y or for f of x. So I could, in any case, go through and just simply pick some values, 0, 1, 2, 3, and plug them in for x. So if I put in 0, I'm going to get 3 times 0 plus 5, and that's just 0 plus 5 is 5. When I put in 1, I get 3 times 1 plus 5, and so that's 3 plus 5, that's 8. When I put in 2, I'm going to get 3 times 2 plus 5, so that's 6 plus 5 gets me 11. And finally, when I put in 3, I'm going to get 9 plus 5, which is 14. So I can go through and graph this. 0, 5 is right here, and then the 0.18 is right there, and the 0.211 is actually right here. But what I want you to notice is when I put 0 into this equation, all I'm left with is that constant value. That's why we know that in slope-intercept form, the constant is where we cross the y-axis. So anytime I want to graph and it's already in slope-intercept form, I'm going to first plot the y-intercept, which is that point I get when I put 0 in for x. I'm going to start by plotting that point. So this is my starting value. And then I'm going to use my slope, and the slope is actually that rate of change. It's the coefficient of x. In this case, the coefficient of x is 3. So every time x gets 1 bigger, you'll notice that the y value increases by 3. So just knowing that this is my slope, I can start here and I can go up 3 and over 1, up 3 and over 1. And then I can take my line tool, my straight edge, whatever it is that you have on hand, and you can connect those points to get the line drawn. Every point that you find on this line now, for example, the point -1, 2, is a point that should satisfy our equation. If I put in -1 for x, and I go through and calculate the value of y, notice that I will get the y value that we're seeing on this line of 2. So using something slightly more complicated, when I look at this one, if I wanted to, I could go through and I could make a t-chart again, x and y. In this case, since I'm going to multiply every x value by -2/3, I might want to pick values for x that are divisible by 3. So rather than going 0, 1, 2, 3, I might go 0, 3, 6. And when I go through and find those values for y then, I'm going to plug in those values just like I did above, but now I'm multiplying -2/3 times 0 and adding 9. So there's that y-intercept again. When I put in 0, what do I get? And I'll always get the constant of the equation. And then when I put in 3, -2/3 times 3, well, 1/3 of 3 is 1, and I want -2 times it. So this is going to get me -2 plus 9 leaves me with 7. If I take -2/3 times 6 and add 9, 1/3 of 6 is 2, so -2 times that is -4. -4 plus 9 is 5. And I want you to notice that when I go to graph this now, 6, 7, 8, 9, so here's my first point at 0, 9. My next point is at 3, 7, which is right here. And my next point is at 6, 5, which is right here. Notice that when I go to graph this, to travel from one point to the next, I'm going to go down 2 and to the right 3. I'm going down 2 and to the right 3. The slope of this line, down 2 and to the right 3, is actually, again, that coefficient of x. So rather than going through the work of calculating all these points, I could simply have started with the y-intercept value and then use the slope, which is my coefficient of x, to tell me my rise and my run from point to point. And then again, I can connect those up with my ruler and my straight edge to make that line. So in this last one, you'll notice the order is slightly different because instead of having the x value first, it came second, but I could fix that very easily by just rewriting it. Because the 4x has a minus sign in front of it, that's going to still have to be in front of it. The 8 was positive. In either case, if I put in 0 to this equation for x, I'm going to get this part of it equal to 0, and so y will equal 8. So I know that that is my starting point, or my y-intercept. So I would start at 0, 8. I'm going to do this one in green. So 0, 8 right here. And then I know that my slope is the coefficient of x. My slope here is -4. Or in other words, -4/1. If I wanted to go through and make a table for this, and I picked my x values to go up by 1s, because I'm dividing by 1 here. Remember, I went up by 3s because the denominator was 3. So here I just go up by 1s. Every time I go up by 1, I expect my y value to go down by 4. So when I put in 0, I got 8. When I put in 1, I get 8 minus 4 times 1. Well, 8 minus 4 is 4. When I put in 2, I get 8 minus 4 times 2. Well, 8 minus 8 is 0. And when I put in 3, I get 8 minus 4 times 3. Well, 8 minus 12 is -4. So notice every time my x value went up by 1, my y value went down by 4. And that's what that slope means. Every time x goes up by this much, y is going to go down by that much. Every time x goes up by 3, y will go down by 2. That's what that slope meant. And so I can come over here and I know I'm going to go down 4 every time I go over 1. I'm going to go down 4 again when I go over 1. I'm going to go down 4 again when I go over 1. And those are the exact points that we calculated in the table here. So whether you use a table of values to come up with points on your graph, or whether you use the slope-intercept pattern to come up with points on your graph, either way will allow you to graph that line. What if it's not in slope-intercept form? There's a couple ways you can do this. One way is what we learned back in chapter 2, solve the equation for y. So if I solve the equation for y, I'm going to get it to say y equals, and then it is in slope-intercept form. So to solve for y means to get this y term by itself. Remember that in order to do that, any terms that are not y, I'm going to want to add their opposite to make them add up to 0. But if I add it on this side, I need to add it on this side also. So I added a -4x to both sides so that this added to 0. And I'm also adding a -12 on both sides so that this adds to 0. So now it says -2y equals 0 minus 4x minus 12. Finally, I'm going to divide by the coefficient of y, and when I do that, everything gets divided by it. So instead of -2y, now I have just y equals, and my -4x gets divided by -2, leaves me with +2x, and my -12 gets divided by -2, leaves me with +6. Now that it's in this form, again, I know my starting point. When I put in 0 for x, I'll get 6 for y. And my slope, which is the coefficient of x, is 2/1. So every time my x goes up by 1, my y will go up by 2. So I can start at 6. And if I go up 2, I have to go over 1. Rise 2, run 1. Notice if I pick any point on my graph, like the point 210, I can verify that this has been graphed correctly because that point should make the equation of the original line true. So here with my original equation, if I've done this correctly, replacing the x with 2 and replacing the y with 10 should make this a true equation. So let's just check that. This is 8, this is 20, and 8 minus 20 plus 12 gets me negative 12 plus 12, which is 0. And that's what I was supposed to get. So I can see that by using my slope-intercept form and the shortcuts of the slope and the y-intercept, I got a line that gave me points making the equation true. So I know that this line is correctly graphed. Another way that I could graph this, rather than turning it into slope-intercept form, and I'll do that here again, we'll practice that method again here. So I'm going to take this line and I want to get it to say y equals. So any terms over here that don't have y in them need to be gone. So I'm going to subtract 2x from each side. This makes this 0 x's. Leaves me with only 5y over here. Since these are not like terms, I'm going to just write that I have a negative 2x and a positive 20. And I could write that in either order as long as the minus is in front of the 2x. Then because I have 5y's, I'm going to divide by 5. And so I'm left with y equals. The negative 2x's get divided by 5. And so that looks like this, negative 2/5 x. And the plus 20 gets divided by 5, and that's a positive 4. So again, I can graph my line starting at 4, because when I put in 0, that's what I'll get, 0, 4. And then that's my y-intercept. And then my slope is that coefficient of x, which is negative 2/5. And so I know that if I rise negative 2, I have to run positive 5. Or in other words, the x values that I would want to pick, my x's, my change in x is 5. So every time I pick a new x, I want to pick ones that are multiples of 5. So every time my x goes up by 5, my y is going to go down by 2. And so I can get these points here. I could go up 2, but then I would have to go left 5. And again, I can check. Here's a point on my graph, the point 10, 0. And I should be able to come back to this equation and replace the x with 10, the y with 0, and see that this in fact makes a true statement. That's how I know for certain that this will be correct. 2 times 10 is 20, 5 times 0 is 0, and 20 plus 0 adds up to 20. So I know that that graph would be correct. My last one right here, same idea. I want to get the y's all on one side with nothing else. So since my y's are here, I'm going to get rid of these. I'm going to subtract 2 from each side, and I'm going to add 8x to each side, trying to get those y terms by themselves. So there's no more constants over here. There's no more x's over here. I just have my 3y equals. Over here, I combine my like terms. My x's get combined together to give me 12 x's. My constants get combined together to give me a minus 8. And now again, my goal, y equals. So I'm going to divide both sides of this equation by 3, making sure I divide everything. My 12 x's get divided by 3. That gives me 4 x's. My 8 gets divided by 3, and that gives me 8/3. So it's now in slope-intercept form. If I put in 0 for x, I'm going to be left with a negative 8/3 for y. Keep in mind, this is a point on the axis. I got to figure out where the heck that is. So 3 goes into 8 twice with 2 left over. So this is the mixed number, negative 2 and 2/3. So on the y-axis, I'm going to go down 2 and 2/3 more. This right there is my y-intercept. My slope, on the other hand, is the coefficient of x. That's my 4. And so my slope is 4, which is over 1. And so every time my x goes up by 1, my y will go up by 4. So from here, I'm going to go up 4. You got to be careful because you're starting part way. So if I go up 4, I'm going to go 1, 2, 3, 4. That's going to put me right here. And over 1. I'm always staying at that 2/3 mark because that's where I started. Now I go up 4 whole units. 1, 2, 3, 4, and over 1. And so then I can connect those points to get my line. A little bit harder to check this one simply because the points that you're using are fractional values, but there's no reason why you can't. This would be the point 2, comma, and then 1, 2, 3, 4, 5, and 1/3. And so I can come back to this equation. I can plug in a value of 2 for x and 5 and 1/3 for y. If I wanted to, I could have gone through and I could have found the x and y intercepts of these lines instead of changing them to slope-intercept form. Let me just show you on one of these only how that would work. Because I know that an x-intercept is a point where I cross the x-axis, and I know an x-intercept is going to have a y value of 0, I can find an x-intercept simply by taking this equation and replacing the y with 0 and solving for x. And so that would look like this. If I put in 0 for y, this becomes 0, and it now says 2x equals 20, so x would have to be 10. And so I know my x-intercept is 10. My y-intercept, same idea, except this time I want to figure out what is y when x is 0. So I'm going to go to my equation again. I'm going to put 0 in for x this time and solve to figure out what is y. So again, when I put 0 in for x, that product becomes 0, and it leaves me with just 5y equals 20. And since 5y equals 20, when I divide by 5, I get y equals 4. So I now have these 2 points, the point 10, 0, and that point's right here, and the point 0, 4, and that point's right here. And if I connect those 2 points up, you'll see that it gets me the same line I got when I was using my slope-intercept form. It gets me that same line that goes through those points. So it's just another way to find the graph of a line. Even with something messy like this one right here, I can still use that technique. If I want to find the x-intercept, I'm trying to figure out what is x when y is 0. So everywhere in that equation that I see a y, I'm going to put 0, and the rest of the equation I'm just going to leave as is, and then I'm going to solve for x. Now this one again is a little bit messier, but the same idea holds. So here this gets me 0, and now it says 4x minus 6 equals 2 minus 8x. And how do you solve for x? Well, when we've done this before, we want to get the x's together. So I'm going to add 8x to both sides. That's going to get those x's all together on one side. And so I get that 12x minus 6 equals 2. And now I'm going to want to get the x alone. So I'm going to add 6 to both sides. And that gets me that 12x equals 8. And when I divide by 12, I get that, simplifying this fraction, x equals 2/3. So my x-intercept is the point 2/3, comma 0. And notice 2/3, 0, that would be right here. That seems like it's pretty consistent with what we were just doing before. It's going to get us that same line. And so I could go through that same process now to find the y-intercept if I didn't already have my line graphed. What is y when x is 0? And I go through the line and plug in 0 for x everywhere I see it and solve for y. Okay, how do I recognize horizontal and vertical lines? Here's the thing with horizontal and vertical lines. When I see a vertical line, every point on that line is going to have the exact same x coordinate. So if I named a bunch of points on this line, they might be like 4, 5, and 4, 2, and 4, -3. But every x value will be 4. So the equation of that line would just say x equals 4. Whereas a horizontal line, when I think about that line, every point on that line is going to have the same y coordinate. So if I found a bunch of points on this line and named them, this might be the point 1, 5, whereas this might be the point 5, 5, and this back here might be the point -2, 5. So since every point on this line has a y value of 5, the equation of that line would just be y equals 5. Only when there's an x and a y both in the equation do you get a slanted line. So when I look at an equation and I see only one variable, I know right away I've got one of these two lines. I'm going to get this to say y equals. Dividing both sides by 5, I get y equals 6. So every point on this line has to have a y value of 6. 2, 6, 3, 6, 4, 6. Every point on the line has a y value of 6. If I plot those points, I'm going to end up with something that looks like this. Y equals 6. is a horizontal line. This one right here, I see only one variable, and it is x. So right away, I know this is going to be one that says x equals something. So I want to get this to say x equals. So the first thing I'll do is I'll subtract 12 from both sides. Get 8x equals -7. Now I'm going to divide both sides by 8 and get x equals -7/8. This is not a slope, even though it's a fraction. It says that every point on that line has to have an x-coordinate of -7/8. So one of my points might be -7/8, 0. One of them might be -7/8, 5. And so on and so on. This is going to be a line that looks like this. That goes through the x-axis at -7/8 right there, and then just simply goes straight up and down. Because this line has both x's and y's, that makes it a slanted line. This is one that I would get to say y equals ax plus b. I would get it in slope-intercept form. Or I would use that technique of finding the intercepts. When I put in 0, what do I get for y? That's where I cross the y-axis. And when I put in 0 for y, what do I get for x? That's where I'm going to cross the x-axis. And I could plot those 2 points, and I'm going to end up with some kind of a slanted line when I do that. It's going to look something like this. This is not horizontal or vertical. However, this one right here has only x's, so I'm going to get this one to say x equals, and I'm going to have a vertical line. This one has only x's, so I'm going to get it to say x equals. I'm going to subtract the 5x first, so it says -4x equals 2. Then I'll divide by -4 and get x equals -1/2. And so that line, every point on that line is going to have an x value of -1/2. That line's going to look something like this. Again, vertical line. All right, last piece right here is writing equations of lines. If I want to write the equation of a line, I just need to know 2 things. I need to know the slope, because that's my coefficient of x, and I need to know my constant, which is my y-intercept. So in this one, they tell me my y-intercept is 8, so I know that this constant value has to be 8. And they tell me my slope is 2/3, so I know the coefficient of x is 2/3. So right away, I can write the equation y equals 2/3 x plus 8. Here they tell me my slope is -5, so I know I'm going to say y equals -5x plus something. And they tell me I go through this point. And here's where you need to recognize that because the x value is 0, that point is my y-intercept. This is the value of b. So plus -4, or what you'll often see written as y equals -5x minus 4. Finally, this one, because I'm given a graph, I need to identify 2 things. Where do I cross the y-axis? So I'm going to count that out. This is -2, -4, this is -6, so I'm crossing at -8. So my y-intercept is at 0, -8. So that constant value is going to be -8. And then the next piece is, what is my slope? And it looks like I'm going up 2 every time I go over 5. I go up 2, I go over 5. And so my slope here, rise over run, is that 2 over 5. So my equation is 2/5 x minus 8. Y equals. Don't forget the y equals or you don't have an equation. And that's how easy it is to write the equation of a line. All you need is the slope and the y-intercept. That was a lot of information here. So if you're having any difficulty with either graphing the lines in slope-intercept form, or the more complicated part, graphing them when they're not in slope-intercept form, or finally identifying and graphing vertical and horizontal lines, please make sure that you come and ask for some extra help. I'd be more than happy to help you out.